science of fire and explosion can be quite complex, but the underlying principles are really very simple. Bringing together a flammable material or fuel with a source of ignition in the presence of the oxygen in the atmosphere will result in combustion. Depending on the particular mix, the combustion can be a slow and mesmerizing fire or a rapid and all-enveloping explosion. Over the years, many industrialized nations worked within their own economies to develop a national consensus on how to evaluate and classify the risks associated with the extraction, processing, and handling of flammable materials in the presence of electrical systems. But it was the growth of international corporations and trade, as well as political and economic reorganization in many regions, that created the need to effectively address crossover electrical installations. The ability to coordinate the methods for these installations in hazardous locations fueled the drive toward worldwide harmonization as an important goal. Largely based on the work of Senelec, the IEC created a series of standards for explosive atmospheres that have now been embraced in a revision of the Euronorm standards, including renumbering for consistency with the IEC documents. And in North America, IEC standardization has also received validation. Although the United States, Mexico, and Canada may be at different stages, revisions to each country's national standards over the past several years have included the path toward harmonization. The fact that the science and much of the equipment theory and technology are so similar between North American and IEC systems makes resolving the points of difference quite manageable and the transition less difficult. Four crucial elements guide the overall process for addressing the use of electrical equipment in hazardous locations, regardless of the system used. The first, and most fundamental, is conducting a risk assessment. Risk analysis involves measuring the prospect that there is sufficient flammable material in the atmosphere to create an ignitable mixture. A variety of approaches are available for the design of these specialized electrical installations. These are made possible by the alternative protection techniques that provide equipment options for the specific hazardous locations. The range of protection techniques can restrict the presence of the combustible mixture, isolate or reduce the energy of the source of ignition, or safely contain or quench combustion that could be initiated by the electrical device. The need to pay particular care to construction has always been integral to the design of explosion-proof and flame-proof enclosures. But many of the alternative protection types also depend on the design and integrity of the housing to prevent physical interference or the entrance of water or foreign matter that could defeat the equipment or component protection. The effort to align with IEC standards certainly moves national, regional, and global installations toward a harmonized approach on risk analysis, classification of areas, and the specification of protection types. But there is one other matter that is directly impacted by this movement, and that is the certification of devices, components, equipment, and assembled apparatus. The IEC EX scheme was developed to address this issue. The intent of the plan was to be able to provide a single, global certificate of conformity based on uniform testing and documentation procedures. Without doubt, quite a range of information is required in order to properly select and specify the protection methods, types of equipment, and precise products to be used in a location that has been classified as hazardous. Certificates and other documentation are absolutely important, but that information must also be easily available directly on the equipment for installation personnel, inspectors, maintenance crews, and field safety engineers. One standard, one certificate, one mark is the harmonization goal, and significant progress has been made. Toward that objective, the IEC marking rules employ the codes and symbols in a specific and consistent format to fully describe the location and protection types that distinguish the product and application. Little doubt remains that worldwide coordination efforts under IEC standards will continue, and the goal of harmonization will be achieved. Killark, a division of Hubbell Incorporated, is an internationally recognized manufacturer of electrical construction products, equipment, and systems for hazardous locations and global applications. Come to Killark.